Capacitor means I am having. Okay, capacitance is the measure of capacitance. Okay, it is sounding like the term capacity, and capacity means the capability to hold something, or you can say the capability to have something. Okay, so capacitor means it is capacitor means I am having. Capacitor is measured is measured in the term of capacitance. Okay, and this capacitance is the measure of energy. It is a measure of energy, and that is what we are going to learn. So I can say that capacitor is an instrument, capacitor is a device, capacitor is a device which is used to store electrostatic energy. It is used to store the electrostatic energy by storing charge. Can you think how beautiful it has been connected? Okay, we are having a device. Okay, we are having a device which is storing charges inside this. Since this device is storing the charges inside this is capability to store the electrostatic energy, because charges contribute to the energy, right? So yeah, therefore I can say that in the form of charges, the capacitor is storing the energy, and that energy is very important for us, because that energy can be used for different purposes, and what are those purposes will be definitely coming across. Okay, got it. So like how does the capacitor, like what is the measure of the capacitor? Capacitor can be measured in terms of capacitance. Okay, measure of capacitor, measure for a capacitor is known as capacitance. So if I want to calculate that what is the capability of the capacitance, I have to take an individual term which is known as a capacitance. Okay, this capacitance is represented by this capacitor has a symbol of C. What is the capacitor? What is the symbol of the capacitor? The symbol is C. Okay, now this capacitance depends upon the maximum charge that can be stored here. This depends upon the maximum charge that can be stored. If I say that I am having a capacitor which is something like this. Okay, this is having the radius r, this, and this is having the charge q. The charge that it holds, the energy it is stores. Okay, if a body is holding more charges, that means it is having more number of it is having more energy inside it. If a body is holding less charges, then definitely it will have less energy than that. Okay, so what is important for us? That capacitance is the measure of the capacity of a capacitor, and that is directly proportional to the charge that it can store, and it is inversely proportional to the voltage of it. Okay, it is inversely proportional to the potential of the device. Okay, it is inversely proportional to the potential of the device. You have to note this. Okay, the capacitor is directly proportional to the charge, but it is inversely proportional to the potential. Therefore I can say capacitance is equal to q by v. The capacitance is equal to q by v. Okay, what does this q by v signifies? Q by v signifies that that capacitance is the ratio of charge to potential. Capacitance is the ratio of charge to potential. Got it? Okay, I hope you got it. So if I say that the capacitance is q by v, so if I increase the charge or if I increase the potential, I can say that the value of the capacitance should, if I just increase the value of the potential, so you'll say that yeah, charges is increasing, so capacitance should increase. But no, that is not true, because if charge will increase, the potential will automatically increase. Increase in the charge will lead to increase in the potential. Increase in charge of the capacitor will lead to the increase in potential of the capacitor. Both will compensate, and the capacitance remains constant. Capacitance remains the constant. So can I say here, just understand this, okay? And why I am saying this? Because I say that this is my capacitor device. What is the potential of this device? That is kq by r. Okay, just put it in this equation. I can say C is equal to q by v, which is equal to c by kq by the distance r here. Okay, easily you can eliminate the term q. After eliminating the term q, I got to realize that it is not dependent upon the charge. The moment you increase the charge, as the charge is increased, the potential is increased. Okay, both of them get compensated, right? Therefore it's said that capacitance does not depend on the charge, does not depend upon the charge and the potential. Capacitance does not depend upon the charge and the potential. It depends upon the size of the conductor, or you can say the medium of the conductor. Okay, instead the capacitance depends on what? It depends upon the size. Okay, like the radius of the device. Okay, it depends radius of conductor. Okay, the medium it holds, the medium it has, or it is present in. Okay, so the value of the capacitance, what does it depend upon? It depends upon the size, and it depends upon the medium. Okay, got it? Were you able to understand this? Perfect. So from this I can draw the conclusion. The conclusion is the capacitance does not depend upon the charge into, okay, yeah, the value of the capacitance is basically charge per unit volume, charge per unit voltage, okay. So if the charge is increased, the voltage automatically adjusts itself and the capacitance remains the constant. The capacitance remains the constant, so I can say the capacitance does not depend upon the current, does not depend upon the charge, and it does not depend upon the potential. Okay, instead it depends upon the size and the medium it holds. Okay, the capacitance is a scalar quantity. The capacitance is a scalar quantity whose unit is mentioned. Whose unit is mentioned as Farad. Its SI unit is Farad. Okay, but we are not concerned with Farad. We are concerned with microfarad, that is 10 to the power minus 6 farad. Because capacitors are generally very small bodies. Okay, like we are not concerned to hold very large amount of charge. With the small charges, our work is like it is done. Okay. So yeah, capacitor is having its unit in farad, but we are generally concerned with microfarad because that is of its practical application. Got it? Okay. Now, if I generally ask you that if this is the device of the capacitor, can you find the capacitance of this capacitor? If the sphere having charge q and radius r having charge q and radius r behaves behaves to store the charge, okay, is it a conductor, is it a capacitor? Definitely yes, this is holding the charge, so yes, this is a capacitor. Can you find the capacitance? What is its capacitance? So yeah, let me find the value of the capacitance. Okay, what I can write about the capacitance? Capacitance can be represented by the term C. C can be written as Q by V. Can I say Q is, and what is can I say Q is Q? And if this is a sphere, the carrying the charge Q and the radius R, can I say that the value of the voltage at the capacitor, this is equal to KQR, that is Q by 4 pi epsilon naught R. Q by 4 pi epsilon naught R. So Q by 4 pi epsilon naught R. Just check, you can cut the value of the C, Q, and the value of C which is left to us is 4 pi epsilon naught R. 4 pi epsilon naught R. From this equation, I can draw three conclusions. Okay, what are the three conclusions? First, the capacitance is proportional to the radius. Okay, it is dependent upon the size of the body. Second, capacitance is proportional to permittivity of the medium, that is epsilon naught. That means it depends upon the medium it is holding. Okay, and the third thing, that capacitance does not depend upon the charge and the potential. The three conclusions, I hope it is clear. What are those? The capacitance does not depend upon the charge and potential, it depends upon the size and it depends upon the medium the capacitor is holding. And remember, any body can behave like a capacitor, only the condition it is capable to hold the charges. Okay.
The problem is not effort, it's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.